Okay guys, I want to go over 2, number 6, and number 9. Okay, so number 6, a couple different things that they're going to have you do. Separate and integrate. Okay, so what I'll do here is let's just make this y plus 1 squared over x squared, and now I'm going to bring everything together. So let's do x squared ln x dx equals, I'm going to expand this, y squared plus 2y plus 1 over y dy. And now we can we could even simplify further on that right side. 2y plus 2 plus 1 over y dy. So now we can integrate both sides. Now on the left side you have biparts. So here, anytime you're using biparts, your u, if you see an ln, make it the ln, because that makes it a lot easier. Du is just going to be 1 over x dx. dv is everything else that you didn't pick. So the anti of x squared is 1/3 x cubed. So here we'll have uv, so 1/3 x cubed ln x minus v du, so that's going to be 1/3 x squared dx, and that's going to equal what's our antis of the right side, which is 1/2 y squared plus 2y plus ln y, and then I always put the c on the x side. So last step, take the anti of this side, and we'll get 1/9 x cubed plus c, and then just rewrite the right side. Okay, and that should be your solution. So just be aware, when you're doing this, it doesn't really matter if you solve for c. If you want to bring all the terms on one side, I believe they're still going to give you credit. If they don't, just let me know, and I'll take a look at the program and see why they're not letting you do that. But I'm pretty sure that they will. Okay, let's go to number 9. Okay, number 9 is dy dx equals y squared minus 1 over x squared minus 1. And then they give you the initial value of y of 9 is 9. Okay, so you're still doing the same steps, separate and integrate. So I have dy over y squared minus 1 equals dx over x squared minus 1. Now this, you got to go back to Calc 2, and this is improper, what's the notation? Partial fraction, sorry. So this is partial fraction. So what you want to do is, if you could factor the denominator, so I'll have x plus 1 plus x minus 1. I could create two fractions from this. If we use common denominators, we would get a times x minus 1 plus b times x plus 1. And then this is going to be all over x squared minus 1. So now you can see that the numerators are the same, and we can then set up our equation this way. So if I want to eliminate b, I can make x equal to -1. Then I would get 1 equals -2a. I'm just plugging in for x there, that -1, so a is going to be -1/2. Same thing, if I want to solve for b, I make x 1, so I get 1 equals 2b. So b is going to be +1/2. And now, because both, it's pretty much the same, just one is with x and one is with y, you would have a negative 1/2 over y plus 1 plus 1/2 over y minus 1 dy equals negative 1/2 x plus 1 plus 1/2 x minus 1, and then dx. So you can see that things are really done pretty closely to the same. Now, I don't want, if everything's to the negative half, okay, I could get rid of that, just divide that out. So we'll just have this. Okay, so if I take the integral, I'll get a negative ln y plus 1 plus ln y minus 1 equals negative ln x plus 1 plus ln x minus 1, and then I put the c over here. So what I want to do now is, if I'm solving for c, I could plug in that initial value. You can see how easy that is going to wind up being, because you'll have things on the same side. So I get a negative ln 10, right, if I'm plugging 9 plus an ln 8 equals negative ln 10 plus an ln 8 plus c. Everything cancels. C is going to be 0. All right, so but how do you solve this for y? Because they're saying y, they want y equals. That's the other thing with the notation. If it says y equals, you got to solve for y. If it doesn't say y equals, I'm pretty sure you could leave it as is, as you get it, as long as it's equivalent. So now, putting that c into 0, we could then start to solve for y. All right, so let's see. Now, your property here, if you have a negative and you're subtracting natural logs, that's really like a division. So you're going to have ln y minus 1 over y plus 1 equal to ln x minus 1 over x plus 1. And now, since you have ln of the same thing, right, or ln on both sides, I shouldn't say the same thing, even though, and it's not the same thing, one's x and one's y, then here you could eliminate the ln. Really what you're doing is applying e to both sides, right, e to that power, so it's like inverse and it cancels out. Now we're solving. So what I want to do is cross multiply. So I get xy plus y minus x minus 1 equals xy minus y plus x minus 1. Cancel. Y minus x equals negative y plus x. So you get 2y equals 2x. So y is equal to x. All right, and the only thing I could say to you guys is, if it's y equals and they give you a little box, you got to solve for y. If, let's see, so if they don't, like in number 6, they didn't do that, you could just integrate on both sides and just leave it as it is given to you. I know the one, number 5, they solved for c, but again, I don't think it matters that they solved for c. I think you could just leave it as long as everything is equivalent. I don't think it matters solving for c. Okay, hopefully that helps.